Hey everyone, welcome to determining if functions are inverses. This is Nicholas JMV. Okay, so in order to determine if two functions are inverses, we have to show the following two compositions. You got to show both of them, okay, in order for this to happen. So the standard, okay, this is something new I'm doing with Common Core. So you're going to verify by composition that one function is the inverse of another. Again, to do that, if two functions, let f and g be two functions. If you can show these two compositions are both equal to x, not that they're just equal, but they have to be equal to x, the functions are going to be inverses of one another. So we're going to look at these two compositions in order to see if functions are inverses. So in order for you to do this video, I'm assuming you can take the composition of functions. Alright, so let's look at our first example. Determine if each is the inverse of the other. Okay, so what we're going to do here is we're going to have f of x is 3x plus 2, and we're going to have g of x equaling x minus 2 over 3. So first composition is going to be f of g of x, and we need to figure that out, which is going to be f of, okay, we know what g is, it's x minus 2 over 3. So that's getting plugged into f. F is 3x plus 2, so we're going to have 3 times the quantity, something plus 2. Okay, sorry, I like to use different colors here. So we have x minus 2 plus 3, and that's simplify. So look what we get here. 3 and 3 become 1. So we're left with x minus 2 plus 2, so that is equal to x. So that one checks out. Okay, and so now let's go ahead and do the second one. Let's look at g of f of x. That's the other one we've got to show. So that's going to be g, let's put our functions back here, g times f. We know that f is 3x plus 2, so there's our substitution. Okay, and we're plugging now, so g of x is x minus 2 over 3, so we're going to have, there's x minus 2 over 3, so I'm going to rewrite that, and now I'm going to plug in my new x value, which my new argument is 3x plus 2. So the numerator simplifies. The numerator simplifies into being 3x. So 2 plus 2, or 2 minus 2 is 0, so 3x over 3, which is equal to x. So we've now shown that f of g of x equals g of f of x, and both of those were equal to x. So we know that these functions are in fact inverses. So that's how you determine if two functions are inverses of one another. Okay, let's look at one more example. Okay, let f of x equal the cube root of x minus 4, and g of x is equal to x cubed plus 4. Let's determine if they're inverses. So again, we start with the composition. So we'll start over here. We'll try to get everything on one page. F of g of x. Okay, so that means f of g. And we know that g is x cubed plus 4. So we're going to plug in x cubed plus 4 into f, right? And now we're going to plug that in. So f is the cube root, so we're going to have the cube root of x. X is now x cubed plus 4. So there's the substitution, and we'll put the minus 4 here. And now we simplify, so we're going to have the cube root of x cubed. And then we have 4 minus 4, which is 0. So it's just the cube root of x cubed, which is just x. Okay? And now we're going to look at g of f of x. Okay, so now we have g, and we're going to plug in f. F, recall, is the cube root of x minus 4. That's going into g. So g is x cubed, so we're going to go cube plus 4, x, and now we plug in the cube root of x minus 4. So if you cube a cube root, you undo that, so that just becomes x minus 4 plus 4. This is equal to x. So we've shown that the two compositions are both equal to x, so these functions, the functions are inverses. So the functions are inverses. Okay, so if you have any questions or comments about how to determine if two functions are inverses, you can go ahead and type them below. We'll see you next time.